All right, welcome to section 7.1. In 7.1 notes, what we're going to be talking about is solving systems of equations by substitution and by graphing. Throughout the chapter, what we're really just working with is systems of equations. Today, specifically, we need to make sure that we are able to solve by substitution. And then in class, we're going to cover how to put these into our calculator and verify our solutions using our graphing calculators. But we want to make sure that we can do all that messy algebra work first. So two methods that we're going to be talking about, one of them in notes right now, and then one of them in notes in class. First one of those is the substitution method. When we're talking about the substitution method, what we are talking about is solving for one variable. So we're going to be isolating one of the variables in one of the equations. And then, as you would guess from the name, substituting the result into either equation. By doing this, it's going to allow me to solve for one of the variables in a way that it gives me some value instead of some expression. Once I have that value, I'm able to then substitute that value into either equation to solve for the missing variable. Graphical method is a little bit different. In the graphical method, we're really going to be using our graphing calculators. And what we do is solve for y in all equations, then graph the equations and find the intersection point. So, substitution method, pretty algebraic in nature. It's going to be a lot more work. The graphical method, only downside, I got to solve for y first, and sometimes that's not really that easy. So we're going to look at three examples today. We'll scale them up in levels of difficulty. So we've got a pretty nice, easy question. We're solving the equation by substitution. And then tomorrow we'll talk about verifying the solution graphically. If I'm looking at these two equations, the easier variable to solve for is going to be y. I'm, for no reason, going to pick the top equation, although the bottom one would probably be easier since it's a positive y. But just to show you it doesn't matter either way, I'm going to pick this equation and say we have 4x minus y equals 1. And if I solve this for y, I'd have y is equal to 4x minus 1. So, substitution method. I've solved for one of these equations, or solved for one of these variables. I can take what I have just gotten as a result and substitute it into the other equation. So now I'll have 6x plus 4x minus 1 is equal to negative 6. That gives me 10x minus 1 equals negative 6. So 10x equals negative 5, and x is equal to negative 1/2. Notice I've gotten a value now because I only had one single variable, and that allowed me to solve the equation. What I can do with this value is substitute it into either one of the original equations. So again, I'm just going to actually pick this one because it's already set as y equals. And since we're solving for y, having an equation that has y equals benefits us. So I'm going to substitute into, I don't know what's with that weird zigzag I just made, this equation. So we'll have y is equal to 4 times negative 1/2 minus 1. That gives us y is equal to negative 2 minus 1. So y equals negative 3. Our answers in all of these questions that have to deal with systems of equations are coordinates, are locations on a coordinate plane. And I write those locations in coordinates or in point form. So we're going to have negative 1/2, comma negative 3. You do need to make sure that you write your final answer as a coordinate. All right, graphically, we'll solve, we'll show you. That'll all be tomorrow, but we're just going to make sure that we know how to do the algebra right now. All right, next we have 4x squared plus y equals 3 and negative x minus y equals 11. The scary thing about that first equation is it has an x squared. But if I look at that equation, I have just a regular y. So I'm going to try and replace that y in order to help me sort of simplify. So I'm going to solve the other equation for y in order to give me something to substitute in. This is negative x minus y equals 11. If I add the 11 and if I add the y and subtract the 11, I get y is equal to negative x minus 11. And this tells me what I will now substitute in for y. That gives me 4x squared minus x minus 11 equals 3. I subtract that 3 over, so I'm going to have 4x squared minus x minus 14 equals 0. And as you, I'm sure, hate it, it is type 2 factorable. Type 2 factoring gives me 4x plus 7 times x minus 2 equals 0. I can set each one of these equations equal to 0. You wouldn't usually have to show this step. I can imagine that you can get it by yourself, but we get x equals 2 and x equals negative 7/4. Having these two different x values tells me that there are two different solutions to this equation. So over here, I'm just going to write the fact that I have two different answers so far, 2 and negative 7/4. And then I'm going to substitute each one of them into the equation for y. So I'll have y is equal to negative 2 minus 11, which gives us y equals negative 13 when x is positive 2. And y equals negative 7/4 minus 11, which gives us y equals positive 7/4 minus, if I convert 11 to a number over 4, it becomes 44/4. This is a 4, by the way. And if I subtract 7/4 minus 44/4, I get negative 37/4. So two solutions to these equations, or to this system of equations, 2 comma negative 13, and negative 7/4 comma negative 37/4. All right, and then last, we have x plus y is equal to 0, and x cubed minus 5x minus y is equal to 0. Again, looking at this second equation, it is a little bit scary because it has that x cubed, but what we can recognize right away is there is a y for me to substitute something into. So if I look at this top equation and solve it for y, I'd get y is equal to negative x. Well, now this becomes not nearly as scary because I'm going to have all variables that are x variables. So I'll have x cubed minus 5x minus negative x, don't make a mistake on that, equals 0. This gives me x cubed minus 5x plus x, which is x cubed minus 4x equals 0. I can greatest common factor this, and what I can take out is an x, and what I'm left with is an x squared minus 4. I can still continue factoring this. What I'm doing here is dots. So this is going to give me x times x minus 2 times x plus 2. 3 solutions to this equation then. I have x equals 0, 0, x equals 2, and x equals negative 2. So I'll start by saying, okay, I've got 3 answers, 0, negative 2, positive 2. And what I have to do is go and substitute those all into either of these equations really, but this is the one that's the shortest to use and the most sensical. So we're going to have y equals negative 0, which is 0. Y equals negative 2, which is 2. And y equals negative positive 2, which is negative 2. That didn't sound confusing at all. So we have 3 solutions here, 0, 0, negative 2, 2, and 2 comma negative 2. Again, for all 3 of these questions, we are going to go over how to verify those results graphically and hopefully get those same answers. All right, thank you.